In this video, we'll take the ideas from the first 3 videos and explore what might happen when very high-frequency electromagnetic radiation passes through large masses, such as planets. If you haven't watched previous episodes of these videos, please click on the link at the top of the screen and start at the first video. Otherwise, this and other videos won't make much sense. While you're in clicking mode, please click on the like button and subscribe to the channel to see more episodes. Thank you. In the previous video, we looked at the consequence of high-frequency, high-energy binary particles passing through matter and colliding with atomic nuclei. We looked at how the energy release from these collisions might cause the heating of matter. Specifically, we looked at how the density of the planet or star will affect the collision rate of these particles with the matter's atomic nuclei, due to the atoms being packed closer together in denser matter. This in turn affected how much energy would be transferred to the surrounding planetary or stellar structure by these collisions. This time, let's look at the effect that spinning charged binary particles might have when they don't collide with the atomic nuclei. The binary particles that simply pass through the atomic structure of matter might cause a very weak drag on the atomic nucleus. The electron side of the binary particle is matter, and so will affect the positively charged atomic nucleus. The electron would be spinning on its own axis and also rotating about the positively charged antimatter positron. Would this produce a magnetic field? If the supposition made in the previous video is correct about space being full of high-frequency, high-energy binary particles coming from all directions, therefore any point in space, an atom would have an equal number of binary particles passing by the atomic nucleus from every direction. The overall effect would be zero, as the drag from one would be cancelled by the opposite drag from another. As mentioned in the previous video, we might expect the atoms to be constantly buffeted by this barrage of particles, but to remain in the same place as the barrage is equal from all sides. So what happens if, for some reason, the number of high-energy binary particles were reduced from one direction? If there is an unequal force applied to an atom by binary particles, then we could expect the atom to be pushed in the direction of the reduced barrage of high-energy binary particles. At this point, it would be useful to use the acronym HEBP for high-energy binary particles, as this term will crop up routinely in this video from now on. The next question is, how could the supply of HEBPs be reduced? The answer from the previous video is rather logical. When HEBPs pass through a large mass of dense matter, such as a planet or star, some of them will impact the atomic nucleus, self-annihilate, and release energy. This will reduce their number. The result of this would be that anything resting on the surface of a planet would have more HEBPs pushing downwards towards the center of the planet than coming through the planet and pushing away from the surface of the planet. So have we a possible mechanism for gravity? Would there be enough HEBPs to cause such a force? To answer this, we have to look at the calculations for dark matter. It apparently represents 85% of all matter. So should we calculate that for every 1 gram of matter there is contained in the same volume 85 grams of dark matter? Or are they mutually exclusive? How should this reduction in the HEBP supply be referred to? The obvious name would be a gravitational shadow. The more complete the gravitational shadow, the larger the difference in the force applied to matter on the side opposite the shadow. Let's now look at how this effect would allow the Earth to hold the Moon in orbit around it. This first diagram shows the Earth and the Moon being bombarded by high-energy binary particles from a source on the upper left-hand side. As the particles pass through the planet and Moon, some of the particles are annihilated as they impact atomic nuclei in the planet's matter. In the diagram, half of the particles have been annihilated. The next diagram includes particles being bombarded from the lower left-hand side. Once again, 50% of the high-energy binary particles have been annihilated through impact with atomic nuclei in the planet's matter. When yet another group of high-energy binary particles are added, moving from left to right, the reduction in particle numbers on the right of the planet and moon becomes obvious. However, the diagram is becoming very complex, and if we continued adding high-energy binary particles from every direction, the diagram would be impossible to understand. To demonstrate the principle, only the high-energy binary particles moving horizontally from left and right are needed. Therefore, let's simplify the diagram and only include high-energy binary particles moving from the left in red and from the right in green. The number of high-energy binary particles passing through the Earth from left to right in this diagram is 21 red particles, whereas 18 pass from left to right due to their reduction by impacts with the Moon's matter. The ratio of the particles pushing the Earth from left to right is 21 to 18. Therefore, the Moon would only have a small effect on the Earth. A small gravitational shadow would therefore be on the right of the Earth. However, the ratio of green and red particles passing through the Moon is 8 green particles passing from the right to left and only 4 red particles passing from right to left. The Earth has blocked 50% of the red high-energy binary particles. Therefore, the Earth would have a large effect on the Moon. A large gravitational shadow would therefore be on the left of the Moon. If this is how gravity works, then it raises some very interesting questions and possible answers. 1. If the force of gravity and the equations governing gravity are constant throughout the universe, it means that we always have the same force of gravity on Earth as would be found in a black hole. This force would be pressing from each side of Earth, so why wouldn't we become crushed? In the second video, the comparison was made that if the atomic nucleus was the diameter of a golf ball, the electron shell would be 1 kilometer away. The atomic structure is therefore anything but solid. If we compare the difference in HEBPs passing through matter with a hurricane force wind, we can see that a wind of 100 miles per hour blowing on a yacht's sail would exert enormous force. If, however, the yacht's sail was made from a tennis net, then the wind's force would be very much reduced. This is like the difference between HEBPs passing through the dense matter of a neutron star to the same HEBPs passing through the Earth. In one case, the same wind, same area of material, but far weaker force. In the case of HEBPs, the same number of particles passing through matter, but a completely different force of gravity. To summarize, the effect of gravity would depend upon the difference in the percentage of HEBPs successfully passing through the matter, or to put it another way, the depth of the gravitational shadow. 2. Scientific opinion is that gravity was present at the Big Bang. This was the force that clumped the matter produced by the Big Bang. If this is the case, then HEBPs would already have been traveling at the speed of light from other parts of space to be able to cause the gravitational effect. These would have to have come from supernovae and/or other Big Bangs. In order for a star to reach the point of supernova or a super black hole to Big Bang, they must have already been in existence for many billions of years. So time could not have started with our local Big Bang. Moreover, the supernovae and Big Bang supplying the HEBPs to enable the clumping of matter in our local Big Bang must also have been formed under the influence of HEBPs from even more distant Big Bangs and supernovae and so on. The prospect of infinite space existing forever raises its ugly head. 3. Our universe is apparently expanding faster than anticipated. Using the explanation of HEBPs for the cause of gravity, it becomes obvious that the universe is sitting in a sea of HEBPs arriving from all directions that cancel each other out. However, there are still weak sources of relatively high-energy binary particles throughout our universe. For example, stars and supernovae. These would tend to exert a small but constant pressure on all matter within the universe. The matter near the outside of the universe would tend to be pushed away from the universe's center. The matter towards the center of the universe would tend to be pushed inwards toward the center. Therefore, the constant weak pressure from the HEBPs would tend to accelerate the matter away from the center of the universe. 4. We know that strong gravitational fields bend light. So how would this work with the idea of binary particles? Let's make a few assumptions. Firstly, there would have to be no direct interference between photons and other EMRs. In particular, no interference between photons and HEBPs. So, the rotating electrons and positrons comprising a single binary particle should not interact directly with other binary particles, meaning that no collisions of two binary particles would take place, and therefore no self-annihilation would be expected. Secondly, in interstellar space, when there is no strong gravitational field, the HEBPs coming from every direction would have to provide a neutral environment through which other binary particles can travel. Thirdly, the rotating binary particle pair will generate a weak magnetic field for both matter and antimatter. If the three assumptions are correct, then a strong gravitational field, that is, strong gravitational shadow, would cause an imbalance of HEBPs and either cause a net magnetic field in one direction, which in turn might act upon photons' magnetic field and drag it towards the gravitational shadow, or alternatively, cause the whole HEBP structure in the area of space, subject to the gravitational shadow to be distorted, carrying the photons along the lines of distortion. This is the closest comparison to the current idea of warping the fabric of space and time that this idea adopts. 5. A few years ago, there was great excitement when gravitational waves were detected from two black holes that were rotating around each other. Again, this was explained as the fabric of space and time being warped by gravitational waves. If the HEBP explanation for gravity is accepted, then the fluctuations in HEBP flow from the direction of an event, such as rotating black holes, just means that a temporary gravitational shadow was created by the black hole. This is the end of the 4th video in the series. If there is enough interest, there will be a 5th and 6th, etc., explaining how the idea of the binary particle can be applied to reflection, refraction, and many other facets of the photon and other EMRs. In the meantime, I hope this short journey into a completely new science has been interesting. We've presented a structure for the photon in which the photon's mass can't be detected because the two particles contained within the photon self-annihilate when in contact with matter. We've seen that the component parts of the photon always move faster than the speed of light. We saw that the photon would be unique as it has a particle and an antiparticle held apart by centrifugal force. This particle has been named the binary particle. We saw how the simple structure of the binary particle would allow it to store different amounts of energy depending upon the speed of rotation of the electron and positron around each other. We confirmed that Newton's law of kinetic energy, namely half mass times velocity squared, is correct, as it would be the velocity within the particle that would be variable, not the mass as proposed by Einstein. We saw how different rates of rotation within the binary particle allows it to provide all the frequencies of electromagnetic radiation without changing its basic structure. We discovered that with the binary particle structure having mass and energy and space being full of such particles, the long sought-after dark energy and dark matter might be a reality. We speculated that the neutrino would be a suitable candidate for a binary particle. Providing a high-energy binary particle, or HEBP, that is capable of passing through solid matter, only releasing its stored energy when hitting an atomic nucleus. We looked at the consequence of having even more energetic HEBPs, releasing huge amounts of energy when colliding with atomic nuclei. The denser the matter, the higher the number of impacts and annihilations, the more energy released, and the higher the temperature. Could this ignite stars when they reach a certain size? We propose that eventually all matter is devoured by black holes, eventually devouring each other, resulting in one single black hole. The end of this comes as a result of the energy within the black hole exceeding the gravity compressing it. The resultant cataclysm and total destruction of the object renders the matter into HEBPs, which finally escape into space. This would be the latest iteration of a Big Bang. We speculated that the rotating electron of the HEBPs would produce a magnetic field affecting every positively charged atomic nucleus within matter. We then looked at the effect of having unequal amounts of HEBPs pressing on matter and speculated that this was the reason for gravity. Then finally we proposed that because gravity is caused by pushing, not pulling, the universe's acceleration can be explained. Not bad for 4 short videos? Your feedback on these videos is welcomed, but please offer criticism based upon logic, not dogma. If you wish to disagree with the concept of the binary particle, that's fine, but as my mother would say, play nicely. If there are mathematicians or physicists watching, your help in either proving or disproving the binary particle concept would be much appreciated. This is the last in the first series of videos. Don't forget to like and share this video. Hit the bell icon if you want to get notified when a new video is released. Thanks for watching. See you again soon.